All right, class.
Yes.
Oh, that's super weak. Let's try this again. Class.
Yes.
Class.
Yes. Yes.
Okay, that's pretty good now. All right, so we're continuing the notes on 5.4. This is example 3, and it is something that we have done already. We've already done this. I've been teaching this since we did back in Unit 1. Whenever we're talking about a sine, cosine, or tangent, those are referring to my x, my y, and my r. And that's what we're doing here. So x, y's, and r's. So we're going to go through and find it for both of these. So we have two angles instead of my s and t like I did on my last example. These ones are using an a and a b. So sine of a is the first thing I'm going to start out. And that's going to be 4 over 5. So new page. Sine of a. And what does sine represent? Y over r. Very good. So I know I need x, y, and r. So my y value is 4, my r value is 5, and we have to go back to a previous, right here, and it says a is between pi over 2 and pi. So if you're looking at your unit circle, what quadrant is between pi over 2 and pi? All right. Pi over 2. Where's pi over 2? Put your finger on pi over 2. Now trace from pi over 2 over to pi. That's going to be quadrant 2. Quadrant 2. That's the best way to try and do this. So you put your finger on the first value, and then you trace over to the next. So that says that A is in quadrant 2. So I'm going back to my notes. So A is in quadrant 2. So in quadrant 2, what do we know about the x value in quadrant 2? It's negative. The x value is negative in quadrant 2. So that's going to help me out here. So I know that. So to find my missing value, I'm going to use Pythagorean Theorem again. So my Pythagorean Theorem is my x squared plus y squared equals r squared. In this case, it's going to be x squared plus, replace the y with 4, equals 5 squared. And we're going to need to do a little bit of math. So 4 squared is going to give me 16 equals, bring this down, x squared plus 16 equals 25. Now, to get my x squared by itself, what am I going to do? Yeah, minus the 16, or subtract the 16 from both sides. So x squared is going to give me 9. Okay, 9. And to undo my square root. So I'm going to square root both sides. So it's going to be x is equal to plus or minus the square root of 9. And because the square root of 9 is just 3, right? Square root of 9 is 3. And we said that this is going to be in quadrant 2. That means it's going to be a negative 3. Does that make sense? Okay, so that's the start. Because all these problems, all the work is at the very beginning. So by teaching you to do it like this using x, y, and r, we do all the work in the beginning. And it's the same work we've been doing over and over again. Now, let's go back to this. So that's my value for A. So now let's look at B. So it says cosine of B, so that's my second angle, is going to be negative 5 over 13. And again, I have my x, y's, and r's, right? X, y's, and r's. So cosine y and r. So what does cosine represent? X over r, right? Okay, now this one's super key here. What do we know about the r value? It's always positive, right? So it's 1 if it's an identity, but these ones aren't the identities. So it's always positive. So since there's a negative there, the negative has to go with my x value, doesn't it? Because this is going to be a negative, so it's going to become a negative 5. The y value is I don't know yet, and the r value is positive 13. And I'm going back again because I need to look at quadrants. It says b is between pi and 3 pi over 2. So on my unit circle, I put my finger on pi, right? Put the finger on pi and trace it over to 3 pi over 2. And that is going to be a quadrant 3, right? So that's quadrant 3. So that's going to be a lot of help right there. So we're going to say B is in quadrant 3. And what do we know about quadrant 3? What is? It's negative, negative, isn't it? So x value is going to be negative, which we already have, right? And the y value is also going to be negative in quadrant 3. So that's good to know there. That's why I get that information over here. So again, we're going to do the Pythagorean Theorem again, which is my x squared plus y squared equals r squared. Plug in my values. Parentheses, negative 5 squared plus y squared equals 13 squared. One of the issues that I've been watching, and I've been helping people out with this, because put the negative in the parentheses here. Because a lot of people keep making the same mistake over and over again. Put parentheses around your negative 5, then square it. Because if I don't do that, it's going to give me a negative 25 there. But put parentheses around it, that means I'm including the negative in my square. So it's a negative 5 times a negative 5, and we know that two negatives give me a, very good. So it's a positive there. So that's what happens when I'm squaring this. So that's going to help me there. Now we're going to get 25 plus y squared equals 169. And I'm trying to get the y squared by itself, so I need to subtract 25. Yeah, subtract 25 from both sides. Yep. So y squared is equal to 144. And we have to square root. Very good. Square root both sides. So y equals plus or minus the square root of 144. And we get, it's going to be a negative 12, right? So it is going to be y is plus or minus 12. But because at the top when we set it up, we said b is in quadrant 3, and the y value in quadrant 3 is going to be negative. So that's a negative 12. Now, these are all the values you're going to need for solving all these problems. So everything else from here is just plugging in values. So we're going to go back to my first page. Wait until you guys finish copying down what I have here. Okay, and we're going to go back to the, not first, we're the first page on example 3. So I'm going back to this, the previous one here. So right here it says find sine of a plus b. Sine of a plus b. So sine of a plus b, right? So what I'm going to do right now, I'm going to write down the formula for this. So from my reference sheet, it's the sine of a plus b. So that's going to turn into sine of my a and cosine of my b plus sine of b cosine of a. Yes, I put these two backwards over here at the end because the pattern, I don't know why, the pattern gets me. I can never remember it the other way. I always have to remember it like this. Sine, cosine, cosine. It's weird. It's one of those things. It's in calculus. I do the same thing too on one of the equations. Now we go to the previous slide from here. So previous slide from here says sine of a. Sine of a. What was the sine of a? What was the value that we had on the previous slide? 4 over 5. Very good. So I'm plugging in. 4 over 5. Now, cosine of b Negative 5 over 13. All right, bring down my plus sign. Sine of the b value? Negative 12 over 13. And cosine of my a value?
Negative 3 over 5.
Very good. Negative 3 over 5. So that's why we did all the work at the beginning, because from here, all we do is just plug in. We're not going to do all that weird identity stuff. We do x, y's, and r's for all of it. So now, when we have fraction times a fraction, we multiply straight across, right? So multiplying straight across. So 4 times negative 5 is negative 20 over 5 times 13, 65. Very good. So bring down my plus sign. Now, a negative 12 times a negative 3. Positive 36, right? Positive 36 over 13 times 5. 65, right? Yeah, we're multiplying. We multiply all these. Now from here, so now I finished the multiplication. Now I deal with the sign in between. So this is my plus sign in between. But they're already common denominators, aren't they? Since they're already common denominators, all I have to do is combine the tops. So I have a negative 20 plus 36, which is going to give me, give me a second. There we go. 16 over 65. Does that reduce?
No.
No, it doesn't. So guess what? I circled it. You know what happens when we circle it, right? That's the answer. That's done. It's not too bad, right? It's just all the work is at the beginning for setting up these problems. So that was, what was that? A, part A. And then the next one was tangent A plus B. Okay? Tangent of A plus B. So in my formula, that's tangent of A plus tangent of B over 1 minus tangent of A times tangent of B. So that's my formula. All right, that's the formula. Maybe? Possibly? Okay, so right here, when we're doing this, tangent of A. Tangent represent what two numbers? Y over x. So I'm going to do y over x here now. Let me change colors. Y over x. So on tangent A, so y value was it 4? Over negative 3. Very good. I'm going to put these in parentheses. Plus sign tangent of B. So negative 12 over negative 5. The two negatives there, what's going to happen to those two negatives? It's going to make it a positive, right? So I have a negative dividing by a negative. So a negative 12 divided by a negative, it's going to make that a positive. So I'm going to show that right here by just changing those to a plus sign. Over 1 minus tangent A is going to be my 4 over negative 3. And tangent B is going to be my positive 12 over 5. Okay, a negative 12, right? Divided by negative 5. So a negative and a negative makes a, there we go. So since it's division, it's the same rules as multiplication. So two negatives together give me that positive. All right, so let's go ahead and do some math here. So to be able to add these together, I gotta do what? Common denominator, right? So common denominator, and so anyone notice anything special here? Can I do it in the calculator? Say yes. Why can't I do this one in the calculator?
Because it can't?
Why can? No. There's something missing. It makes me able to do it in the calculator.
Variable?
Not variable, but yeah, that would be a problem.
There's no tangent in them?
No.
Like just a number?
No. There's calculator doesn't like radicals because it will give you a decimal all the time. Right? So as long as there's no radicals in this one, I could just plug this in the calculator as is. So I'm going to show you how to set this up in the calculator. All right, here we go. So scratch pad. So control divide, right? So there's my top. And now I'm going to control divide again because this is going to be, what was that, 4 over -3, right? Yes? Yeah. Okay, the next one is going to be plus, was it plus or minus? Plus, so I put my plus sign and control divide again. And that was my 12 over 5, very good. Now I move to the bottom of the fraction right here, right? I move to the bottom, so it's 1 minus control divide, and that was my -3, right? Very good. And what did I do to that 4 over -3?
Nothing.
No, there's something I have to do here. What's the operator I'm going to put? It's times, isn't it? Because the two things are right next to each other, that's implying there's a multiplication.
I thought you put parentheses.
I did. I used parentheses on my other one. But that means it's multiplication too. I could use either.
Okay.
So right here, this means multiplication.
Yeah.
Okay?
So that I'm saying in the calculator.
Oh, on the calculator, you could use that too if you want. So let me get back to the calculator. So it's going to be times control divide, and that was my 12 over 5. And by doing that, I end up with,
That's the answer?
so I'm going to do it again, but I'm going to do it with parentheses this time. To show you, you could just plug it in as is. So I'm going to start, oh, I can't get to the left parentheses there.
Oh, wait, just copy that.
Huh?
Just copy that.
Oh, I'm going to start it out with the parentheses because when you do it, it's slightly different. So parentheses, now I do control divide. Right here, now it sets it up. Now it sets it up just this fraction. So that was my 4 over -3. And then I close that parentheses, and then it was plus. And then I do a open parentheses here to do this. Then I go control divide. So that's what made it slightly different. So it's the order of doing it. Close that, and then go over here. 1 minus, open it there, control divide, 4 over -3 over, close it, yes, and then open it again, control divide, 12 over 5, and then I'm closing off my last one.
How do you put this in?
Say what again?
How do you control divide this whole thing?
You have to start with a control divide. You have to start with it. So that's what I had to do first, and then I put each item in. So yeah, that's what your problem is. You had to start with control divide. Okay? So control divide, and now right there, open it,
Oh.
and then control divide. That's the difference, okay? All right, so 16 out of 63. Hey, what are you doing? No, good. Keep doing nothing but over there. Hey, hey, hey. Put that stupid thing away. Hey, no. Put it here. Put it here. Set it down and walk away. Set it down and walk away. Okay. All right, so 16 over 63 is my answer for that.
Can you write like calculator options right quick?
Okay. In calculator.
I do not know how I got this.
Okay. So we have another one now. So that was example B. Now let's C. All right. So let's take a look here. So the quadrant of A plus B. So I got to look at my notes on this one because I thought I had like a trick for this one. I thought I had a trick for this one to make it easier. Huh?
For some reason I got like -1/3.
-1/3?
I got the same thing. I think I multiplied the 1 instead of putting 1 minus 4/3. No, it's already done.
I know you're not on your phone again, right?
But I multiplied.
Oh, that's why.
Yeah.
So you fix that, it's supposed to be a 1 minus your answer.
Oh, you can do that?
Yeah, just copy and paste. All right. So let's think about this. Now we're trying to figure out quadrants here. Okay, listen up, please. Now for part C, we had sine of A plus B. We came up with an answer of, what was my answer on that one? 16 over 65. Right? So 16 over 65. And let's see, so 16 over 65 for that one. And tangent was
16 over 63.
all right, so now from there, right here, are they both positive? They're positive, right?
The first quadrant?
Yeah. So since sine is only positive on my unit circle, sine is positive right here in quadrant 1 and in quadrant 2, right? Say yes.
Yeah.
So sine is positive in quadrant 1. So that means that when I add them together, it's either quadrant 1 or quadrant 2, right? Yes? So that means quadrant 1 and quadrant 2. And the tangent. Tangent is positive, isn't it? So yes. Okay, tangent is positive. Where is tangent going to be positive at?
1.
It's in positive, is in 1, and it's also in 3, because 2 negatives will make a positive. Right? That's where we get these ones from.
All the answer?
No.
Just 1?
You'll see. Yeah. My final answer. So it's asking, where is it going to end up at? So if I only looked at A, it would tell me it's either in quadrant 1 or quadrant 2, right? And if I was only looking at B, that would tell me it's either in quadrant 1 or quadrant 3. But what do they have in common?
1.
Just 1. So since they both have 1, my answer is going to be quadrant 1. Yeah. Yes.
So you're just looking at where, like for sine and tangent, you're just looking at those values and whether it's like positive or negative or not.
Yeah.
And then
Because
whether
sine is positive in quadrant 1 and 2, right?
Right.
So, yes, and then just look at tangent. Tangent is only positive here and here. So the ones they have in common is just quadrant 1. So that means this one has to be the answer. Does that make sense?
Yeah. So
Okay.
they have to be both positive for tangent, right?
Yes, both positive or both negative. And so that's why quadrant 1 works, but not quadrant 3, because it wasn't the same in sine, right? Does that make sense?
Yeah.
Hopefully. Okay, are we good so far? Because I'm going to pause it here, then we're going to look at the example 4. So I'm going to give you about 10 minutes to start the problems, and then we're going to do example 4, okay? Yes?
Yeah.
Okay, good. All right, so we're continuing what we have. So we're verifying that this is identity. So what I need to do here, I need to go through and expand this. So I'm going to start by expanding my first one. Sine of, this is basically my A and my B. So this right here is going to turn into sine of pi over 6 times cosine of theta plus sine of theta times cosine at pi over 6. That is this. That is all that. Okay, I'm going to put this in parentheses so you can see. That's all that right there. Now the next piece, I'll put this one in blue. Plus, now we're doing all of this. Now I'm using a cosine formula this time. Now from the reference sheet, the cosine formula is cosine, cosine. You remember that? It has cosine, cosine from your reference sheet. So cosine S plus T or cosine A plus B. So that's going to turn into cosine of pi over 3 times cosine of theta. And what symbol goes next? What symbol goes next? If this is right here a cosine identity, it's a minus sign right there.
Oh, minus?
Yeah, if you're looking, you have your reference sheet in front of you, right? So it's cosine of S plus T. So that means that there is a minus sign here. So you can check the reference sheet if you're questioning it. So now it's going to be sine at pi over 3 sine of theta. So that's everything on the left side here. Everything on the left side. It's saying that's going to end up becoming just cosine by itself. So we're going to do all the work here. So I'm going to start plugging in the values that I know. So the values that I know, sine at pi over 6. So from my unit circle, sine is the y value at pi over 6. That is 1/2. So it's going to be 1/2 times cosine of theta. Now the next one, cosine at pi over 6. Rad 3 over 2. So it's plus. So it's rad 3 over 2 times the sine of theta. You agree? Yes? Okay. So I put the real number in front of the variable. So sine theta, I'm treating that like my variable there. So the number goes out front. Bring down my plus. Cosine at pi over 3. 1/2 times cosine at theta, right? Now, minus. So sine at pi over 3. Rad 3 over 2. Times sine of theta. I'm just plugging in the known values and putting it together. Okay? So, the next part right here is going to be key. So we look to see, let's start by combining our common variables. So I said that I'm going to treat the cosine theta like its own variable, right? So we can only combine that with other cosine thetas, right? So I have a cosine theta here, so I have 1/2 cosine theta. That was supposed to be purple. And I have another one over here, right? So together, that's going to give me what? 1, right? A half plus a half is 1 cosine theta. Now the next thing I have is, I'll use this ugly color right here. Actually, no, orange is uglier. There, let's do that one. So the next part I have is a sine theta. Sine theta is a different variable. It's a sine theta. So it's going to be right here, which is a positive rad 3 over 2, right? Yes? Now let's go over here. We have a negative rad 3 over 2 here, sine theta, don't we? So when I combine those two things together, I get 0. That's going to be 0 because I'm adding rad 3 over 2 sine theta, and I'm subtracting rad 3 over 2 sine theta. So when I combine those two together, so adding those or combining those, it's going to give me just 0, right? So that's going to give me plus 0. So I don't really even need to put the plus 0 there, right? But I'm doing it here so you can see by colors that that just became 0. So now let's go back and look. So is this the same as that there? Yeah. It's the same thing. So you're just lining it up, combining what you have, and it will simplify to something like this. All right, does that make sense? Anyone have any questions over this? No? Okay. So I'm going to stop right here. So make sure you like, yes?
So you got the 1/2 from the unit circle, right?
Yeah, the 1/2, so sine pi over 6 was 1/2 times the cosine theta, which put that together right there. Okay? All right. Like, share, and subscribe. Hit that notification button.
Can I use the restroom?
Buy stuff from my merch store.